Hi, in this video we are going to look at the present value of a series of equal cash flows. So what do we have here? So we have an ordinary annuity that has equal payments. This is the first point. The second point is that the first payment occurs at t is equals to 1, and in total the annuity max n payments. Now the question is, as we can see here, the question is what's the present value of this annuity? Now it's always good to do an example so that it's so that it's easy to understand. So we're going to do an example. So let's import our example. All right, let's import our example here. So suppose you're considering purchasing a financial asset. Okay, that financial asset could be anything: a stock, a bond, a real estate, any asset, any financial asset, right? That financial asset promises to pay 1,000 euros per year for 5 years, with the first payment 1 year from now, which is 1 year from now. So first payment always occurs not at the present time, but one period after the present time. In our case, the length of one period is a year. So because we're talking about years here. So first payment occurs at the end of the first year, that means. And at the end of each year, for the next 5 years, this financial asset promises to pay you 1,000 euros. Okay, now, and the required rate of return on this financial asset, the interest rate that the bank you're purchasing this financial asset from is paying you per year is 12%. Now, how much should you pay for this asset at the present time? So, as usual, let's draw a timeline to better visualize this problem. So, there's this timeline, and this is year, right? So, we have year 0, end of year 1, end of year 2, end of year 3, end of year 4, end of year 5. First year, second year, third year, fourth year, fifth year, 5 years. So at time is equal to 0 here, let me change my pen here. At time is equals to 0, you purchase a financial asset. And this financial asset that you pay at time is equal to 0 promises to pay 12% per year. This is compounded annually, 12% every year. Now, the question is, how much should you pay for this instrument now so that it pays you 1,000 euros at the end of each year? Usually we'll have a negative sign, negative 1,000, negative 1,000, negative 1,000 when a cash flow goes out of an account. That is, if you're getting paid, we usually do it negative cash flow, but for this purpose, let's just say it's just $1,000. But this cash flow is out of the account because it's being paid to you. So this is basically the problem. The problem is, how much should you pay at the present for this financial asset? Uh, so the formula for this is present value equals the annuity amount multiplied by 1 minus 1 over 1 plus r raised to n divided by r. So where A is 1,000 euros, right? R is 12% or 0.12, and n is equals to 5 years. Now just substituting this in here, we will have 1 minus 1 over 1 plus 0.12 raised to 5. Let me just make this a little longer. Divided by 0.12. And this will give us an amount of 3604.78. So 3,600, around 3,600 euros. So purchase this instrument now from a bank, for example, purchase this asset for about 3,600 euros, and at 12% interest rate, at the end of each year, you will be able to generate about $1,000. Look at this, okay? So a thousand, a thousand, a thousand. So in 5 years, 1, 2, 3, 4, 5. In 5 years, you collected about how much? $5,000, right here, 5,000 euros. But you only paid about 3,600 euros at the present time. How come you have $5,000 at the end of the 5th year? Because of the interest rate, right? So you have to pay this much amount of money to pay this financial instrument today, so that it will pay you $1,000 at the end of each year. And these $1,000 are equal amounts year after year, and that's why we call them equal cash flows. They are not different from year after year. Thank you for listening.